Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we would be seeing how to solve quadratic equations using the formula method. Now, why do we call this as formula method? Because here we are going to use a specific formula to calculate the roots of the given quadratic equation. Now, if let's say we have a quadratic equation ax square plus bx plus c equals to 0, where your a is not equal to 0, then the roots of these quadratic equations are given by the formula x equals to minus b plus and minus under root of b square minus 4ac upon 2a. Now, this formula is derived with the help of a particular procedure, we can say, and if ever you want to know the proof of it, you can mention it in the comment section so that I can explain you as to how did we actually derive this formula. Now here if you see b, a and c, these are basically the coefficients of x square, x and the constant term respectively. So we would be using this formula wherein the first value of x is minus b plus under root of b square minus 4ac upon 2a, and the second value for the x is minus b minus under root of b square minus 4ac upon 2a, and this is how we would be getting two values for the given quadratic equation. Now let us start solving the first problem. So the question is x square plus 6x plus 5 is equal to 0. We are first going to compare the given quadratic equation with the standard form, which is ax square plus bx plus c equals to 0. So comparing with the standard form, we get a ka value as 1, b as 6 and c as 5. Again, the signs of every coefficient and the constant term over here is very important, and that is why you don't just have to pick up the number, but you have to pick up the number along with its adjacent sign. So here, since 1, 6 and 5 all are positive, that is why the values we have just taken 1, 6 and 5. Now let us substitute these values in these two formulas. So by formula method, we know that the value of x in this case by using formula method is minus b plus and minus under root of b square minus 4ac upon 2a. Now instead of b we would be putting the value as 6. For a we would be putting the value as 1. For c we would be putting the value as 5 upon 2 into, now again here a ka value is 1, minus 6 plus and minus under root of 6 ka square is 36 minus 4 into 5 is 20 upon 2 into 1 is 2. So we get minus 6 plus and minus under root of 36 minus 20 is 16, the whole upon 2. Minus 6 plus and minus, we know that square root of 16 is 4 because 16 is the square of 4. Now that is why we get two values. So x is either equal to minus 6 plus 4 upon 2, or your x is equal to minus 6 minus 4 upon 2. Now why these two values? Because here we have two signs plus and minus. So we have minus 6 plus 4 upon 2 and minus 6 minus 4 upon 2. Now normal addition, minus 6 plus 4 is minus 2 by 2. So one value of x is this, and minus 6 minus 4, both of them are negative. You are going to add and give a minus sign. So we get minus 10. So x in this case is equal to minus 1 when we reduce both of them, or your x is equal to 10 by 2 is minus 5. Since this is a quadratic equation, that is why we would be having two roots or two solutions for the given quadratic equation, and hence the values for x in this case would be minus 5, minus 1 or minus 5. Similarly, we are going to solve the next problem. The basic approach for this particular problem would remain the same, hence I would be keeping the general details Same. Here the second question is 5x square plus 13x plus 8 equals to 0. 5x square plus 13x plus 8 equals to 0. When you compare this with the standard form, we see that A is 5, B is 13 and C is 8. Again, all three of them are positive because there is no negative sign involved. So A ka value in this case is 5, B is 13 and C is equal to 8. Once we have got the values for A, B and C, then we are supposed to mention the method that we are using. Now since we are using the formula method, that is why we have mentioned by formula method. Mention the formula, don't directly just write the values. And now try to substitute every value for the given variable or for the given alphabet that we have used. So B in this case is 13 plus and minus under root of 13 square minus 4 into A is 5 and C is 8. The whole upon 2 into, again your A is 5. Now minus 13 plus and minus under root of 13 ka square is 169 minus 4 into 5 is 20 and 20 into 8 is 160. The whole upon 2 into 5 is 10. So x in this case is 13 plus and minus under root of 169 minus 60 is 9. The whole upon 10. Again, this is equal to 13 plus and minus 3 because 9 ka square root is 3 or 3 ka square is 9. Hence, we get two values for x. Ek aa jayega 13 plus 3 upon 10 and the other one would be x equals to 13 minus 3 upon 10, which is 13 plus 3 is 16 by 10 and 13 minus 3 is 10 by 10. We know that any number when divided by 10 would be, and if it's a whole number, you just have to, leave one place and add the decimal number over here. So 16 by 10 can be written as 1.6 and here this gets reduced to 1. So the two solutions for the given quadratic equations are 1.6 and 1. Now let us move on to the third question. Again, we would be following similar approach of just substituting the values in the given formula and get the answer. In exam, if no method is mentioned, then you can directly use this because this is the most easiest one. And if at all the respective method has been mentioned, like the factorization or the completing square method or even this one, then you have to use the mentioned or the specified method. Now the third question over here is 5m square minus 4m minus 2 equals to 0. Again, we are going to compare the given equation with the standard form, which in this case is ax square plus bx plus c. So here a ka value is 5. Since we are comparing this with plus b, so here plus b is your minus 4. That is why your b ka value would be minus 4 and similarly your c would be minus 2. Now use these values in the formula. So let us substitute. Instead of b, we would be putting minus 4. Mind it that there is already a minus sign outside b. So this minus sign is different from the minus sign that is there along with the number 4. So keep your minus sign outside. Inside the bracket, write whatever is the relevant value of b, which in this case is minus 4, plus and minus under root of minus 4 the whole square minus 4 into a into c, which is 5 into minus 2. The whole upon 2 into 5. Minus 4, minus into minus becomes plus. So we are going to write 4 over here, plus and minus under root of. You know that square of any negative number is always positive and that is why minus 4 ka square is 16. Again, 4 into 5 is 20 and 20 into 2 is 40. We have minus over here and minus over here. So minus into minus becomes plus. So we have 16 plus 40. The whole upon 10. So your x in this case would be 4 plus and minus under root of 56 the whole upon 10. Now this can be written as x equals to 4 plus under root of 56 upon 10, or x equals to 4 minus under root of 56 upon 10. Now, since we can write 56 as under root of 8 into 7 the whole upon 10, or your x can be written as 4 minus under root of 56 again can be written as 8 into 7 the whole upon 10. Now this 8 can again be written as 4 into 2. So we have 4 into 2 into 7 the whole upon 10, or similar kind of calculation can be done for the other term as well. So we have 4 into 2 into 7 the whole upon 10. Now since this is in multiplication, if your root has all the terms in multiplication and if at all there is a square term that is there inside the root, you can take it out of the square root and write uska equivalent square root value. So what is the square root of 4? It's 2. So you can take 4 bahar. You can only take 4 bahar or outside the square root only because the operations involved in the square root inside the square roots are multiplication. So that is why when you take your 4 outside the square root, you get the answer to be 2 under root of 2 into 7 is 14 the whole upon 10, or x equals to 4 minus, again this 4 comes out of the square root, inside the bracket 2 into 7 upon 4. Now here if you see, this is where your calculation stops. Now here you have to see, since there is a root that's been included over here and you don't know what's the value for root 14, that is why you would see whether you can reduce this ahead by taking some terms common from the numerator and then reducing it with the denominator. Here if you see, in the numerator there are two terms, both in this particular value and in this particular value also. Like here the first term is 4 and here the second term is 2 root 14, and the common multiple in both these terms is 2. That is why you're going to take 2 common. When you take 2 common, what would be left inside the bracket is 2 plus under root of 14 the whole upon 10. This is your first value. Similarly, you're going to take 2 common from here. So you would be left with 2 minus under root of 14 the whole upon 10. Now can you reduce this 2 and 10 with each other? So we can. So 2 ones are 2 and 2 fives are 10. Similarly, you can reduce the numerator and denominator in the second value also, and that is how the final values or the solution for this particular equation turns out to be x equals to 2 plus under root of 14 by 5, or x equals to 2 minus under root of 14 by 5. And these are the two solutions for the given quadratic equation. So in today's class, we started by knowing what is the formula method in order to solve a quadratic equation. We pretty much saw that this is one of the easiest method to find the solutions for the quadratic equations, because it is directly a formula based approach wherein you would be directly using this formula without making any kind of modifications or simplifications which you did in the completing square method or the factorization method. Use the values of the coefficients and the constant term over here and find the values for x, that is find the roots for the given quadratic equations. So with this we come to the end of today's class. I hope you all have understood what has been taught in today's video. If you have any doubts, any confusion, you can pin them down in the comment section and reach out to me. Thank you so much and see you soon in the next video.